Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. This video is about next time question from previous video, and this is about Kirchhoff's laws. This lesson will help you to improve your understanding of KCL and KVL, and it will also give you more confidence to solve complex DC circuit problems. Here is our next time question from the previous video. So this question is simply asking us what is value of current passing through each battery. Or I can simply say you need to find what is I1 and you need to find what is value of I2. In order to answer this question, we need to understand KCL and KVL. I have already explained KCL and KVL in detail in previous videos on Kirchhoff's laws. You can go back to the channel and you can search for KVL and KCL. So I will also give you a little review of KCL and KVL, because if you are not clear about KCL and KVL, it will be quite confusing. So let me explain to you a little bit about KCL. Let's say we have a junction here. Let's say junction is like this junction, and here let's say current I is entering. This is a junction node, also sometimes we call node, and here current is I2 and here current is I3. So according to KCL, for any junction I entering has to be equal to I leaving. Means I entering into the junction has to be equal to I leaving. Okay, so in this case you can see I1 is entering and I2 is entering. We can simply say I1 plus I2, and this is equal to I3. So this is KCL in a nutshell. So next one, let's try to understand what is KVL. For KVL, we need to simply understand, if I have this simple circuit, let's say this is our resistor here, this is our simple circuit. According to KVL, in any loop, delta V has to be equal to 0. So let me draw one more resistor here. So let's say we have two resistors and one battery. So first thing we need to understand, what is a loop. Loop simply means if I start from this point, I go this way and I come back to the same point. This closed shape is called a loop. And also loop we can define a little bit in a different way. Let's say I start from this point again, I go like this and I come back to the same point. So this is also one loop. So loop also we can define, let's say I start from this point, I go this way and come back to the same point. Again, I form a closed loop. So this is simply loop. The point you start, you come back to the same point. So that is closed loop. So in any loop, for example, at one point, delta V has to be equal to 0. So this is what KVL is telling us. So there are some more points we need to understand. So we will be very good to answer this type of question if you understand these points as well. So now let me explain to you about battery. And here is resistor. We will follow these conventions. Okay, so for battery, for example, if we go from positive terminal to negative terminal, let's say if we go from positive to negative terminal, in this case voltage will drop, V will be minus. And if we go from negative terminal of the battery to the positive terminal, V will be positive, we will gain voltage. For resistor, let's say this is resistor, and let's say current is flowing to the right. If we go in direction of current, V will drop, V will be minus. If we go in direction opposite to the current, we will gain voltage and V will be plus. So we will follow these conventions and we will just stay with these conventions. So you have to be quite clear. These are the key concepts. If these concepts are clear to you, this question is not difficult at all. We just need to follow these steps and just solve it. So let's try to solve this now. Okay, step number 1. So what is over step 1? Step 1, always we will follow KCL. Step number 1, we have to write down junction equation. So this is step 1. Junction equation we need to write down. And this is based on KCL. So how we can write junction equation? As you can see here at this point, current entering is I1. I can also write down here, this is I1, I2, and I3 is leaving. So simply we can say I1 is entering and I2 is also entering. So this is equal to I3. So this we can also say equation 1. Okay, next step. Okay, this is equation number 1. Let's go to next step now. Step number 2. So here is our next step. So I can also write down, this is step number 2. So we have to choose a loop. You can choose any loop and you can take any direction. But in this case, to make this question simple, I will choose first of all left loop and I will follow clockwise direction. So if I start from this point, let me also write down, this one is left loop. So if I cross battery from negative to positive, we will gain voltage. So gain means plus 9. Plus 9 volts we will gain. Now if we go in direction of current, we will lose voltage. So we will say this is 18I1. So also you have to be clear, according to Ohm's law, V is equal to I times R. So that's the reason I wrote here 18I1. Now if we go from B to D, mean in direction opposite to the current, we will gain voltage. So it means this will be plus 6I2. And we go positive terminal to negative terminal, we will lose volts. So this will be 3 and this is equal to 0. Now we can simplify this one. So we can write down 6 minus 18I1 plus 6I2. So we can also say this is equation number 2. Now we need another loop because we have to find I1, I2 and I3 is also involved. So we need at least 3 equations. So the third step. So let's choose right side loop. Right side. So for the right side one, let's say we start from this point and we go clockwise. So this is our right side loop. Now when we go from negative terminal to positive, we will gain voltage. So it means 3 volts. And when we go in direction of current, we will lose voltage. It means this is 6I2. Now again we go in direction of current. So we have this is minus 3I3 is equal to 0 because there is no any resistor and battery here. Now as we can see here is I3, but we need to find only I1 and I2. So we can replace I3 with I1 and I2. So as you can see here, so we can simply write down this is 6I2 minus 3. I3 we can replace, as you can see here, is equal to I1 plus I2. So I can say this is I1 plus I2 and this is equal to 0. We can more simplify this. If we simplify this one, so what we will get this is 3 minus 3i1 minus 9i2, and this is equal to 0. This is equal to 0. Now let's say this is over third equation. So this is third one. Now if we look at 2 and 3, now you can see here we have 3i1, here we have minus 18i1. So if we can cancel i1, then we can get value of i2. So let's try to cancel i1 now. In order to cancel minus 3i1, we have to multiply this by 6. So let's multiply this one by 6 on both sides. So minus 9i2. This is equal to 0. If we multiply with 6, again you will get 0. So what we will get here, this will be 18 minus, we will get 18i1, and minus we will get 54i2. So here, let's say this is equation number 4. This is equation number 4. Now, as you can see here, let me change different color. As you can see here, this is equation number 2 is here, and equation number 4 is here. 4 is here. Now, as you can see, we have minus 18i1 in equation 2, and also we have minus 18i1 in equation 4 as well. So if we just subtract, we can simply cancel. Now, let's say equation number 2 minus equation number 4. So the 2 is 6 minus 18i1 plus 6i2. This is equal to 0. And here we have, this is 18 minus 18i1, and we have minus 54i2. This is equal to 0. Now we have to subtract this one, so this will be minus, plus, we just need to change sign. Now we add this. If we add this one, so 6, 18, this is 6, and this is minus 18. What we will get? We will get minus 12. And this is minus plus, so simply i1 we can cancel, and here what we will get is 6 plus 54, we will get 60i2, and this is equal to 0. Now we can solve for i2. Simply what we will get, 12 divided by 60, and if we simplify, we will get, this will be 0.2 amps. So I2 is equal to 0.2 amps. So we can also say I2 is equal to 0.2 amps, or this is equal to 200 milliamps. So this is our answer for I2. So this is our answer for I2. So this is how we can find. As you can see, our answer is here, 200 milliamps. Wonderful. So we have got value of I2. Now we need to find value of I1. Okay, so as we have value of I2, we can find value of I1. So let's take equation number 2. So we can write this is 6 minus 18i1 plus 6i2. 6i2. So as you can see, this is 6i2. So we can replace with value of I2, and this has to be equal to 0. So if we simplify this one, what we will get? We will get is 18i1 will be equal to 7.2. So from here we can get value of I1 means 7.2. We simply need to divide by 18. So if we divide by 18, we will get our answer is 0.4. So it means I1 is equal to 0.4 amps, or we can say this is equal to 400 milliamps. So this is our final answer for I1.